Now, excuse me guys, please remember that anytime you see a triangle, triangles are always half a rectangle. You got it? Every time. So basically, if I said triangle A, and this is triangle B, and this full one is C, triangle A plus triangle B equals the same size as triangle C. That makes sense? Triangles always cut a rectangle in half. So basically it's the length by the height. Now what it's telling you is that it's 20 multiplied by the height, half the answer. So what's 20 multiplied by the height? 20 multiplied by the height is 20h. And what's half of 20h? 10h. 10 times h has to equal 80. So what does that mean about the h value? 8. Well, I keep saying this year is the biggest difference between me and you is I always think I'm wrong. So I always have a quick look back and go 8 times 20, 160, half it, 80. And now I'm convinced I'm right. Okay, that's the difference. Now once again, over here, it's a half base times height. In this case, it's actually not half a rectangle, it's half a, would you agree it's half a parallelogram? And how do you get the size of a parallelogram usually? Half a parallelogram is the base times the height. So it's a half the base times the height for the triangle. So a half 120 times h. So what's half 120 times h? Anybody? 60h. And it tells me that 60h equals 50 by 18, which is 900. 60h has to equal 900 because you're told the two areas are the same. So what you get? 15? Okay. Shh. You can check your answer if you want. Right? Now, this one here, they ask you to get your ruler and measure it myself. So on my ruler it could be any distance, but myself and Krill calibrated my ruler earlier while we were waiting on you. So does it say it's a square or a circle? It says it's a square, isn't it? So I think we'll just go for 5.5 for both of them, okay? So is everybody happy with that being 5.5 centimeters this way? Then if I rotate it around, it should be 5.5 centimeters the other way. Is that okay with you guys? Now, the problem is it tells me it's a scale of 1:80. What does that mean? What does that mean, a scale of 1:80? It appears 80 times bigger in real life. So, what's 5.5 multiplied by 80? I'm going to go for 440 centimeters. 440 centimeters is how many meters? 4.4 meters. Is everybody now happy that the actual size of your area is 4.4 meters by 4.4 meters? Everybody cool with that? It wants me to find all the gravel. Where's the gravel located? I'll colour it in yellow. Gravel's usually yellowish. So that's some there, isn't there? There's some all the way down here. There's some here. And there's some here. I'm in a class capable of calculating the gravel for me. How'd you do that? Get the area of the square, take away the area of the, off you go. Do it now. Be quiet, look at me. Now, first thing we're going to do is we're going to get the area of the square. So the square is 4.4 multiplied by 4.4. Will somebody give me the answer for that? 19.36. What? 19.36. Shh. 19.36. Next thing. We want the radius of the circle, which is half the 4.4, which gives me 2.2. Next thing you want after that is you want to get the area of the circle. The area of the circle is represented by this blue section here. There's a formula in your notes. The formula says that the area of a circle is pi r squared. The pi button comes from your calculator. Does everybody know the location of the pi button? Okay, you press pi, you press 2.2 squared, and what answer did you get? Change it to decimals for me if you get an answer. 15.205. It had to be smaller than 19. Why did it have to be smaller than 19?
Because circle is less.
Yeah, circle is smaller than square. So 19.36, take away your, what's it, 15.21, call it, because we have to round it off anyway. So what do we get?
4.15.
And you're done. The yellow area, or the area of the gravel, is 4.15. Ready to move on? Okay. Now, what happens is we have a rectangle, no bother. The rectangle has an area of, what's it, 300 and, so that's a square. A rectangle has a length of, a rectangle has an area of 320. Its length is 40. Just divide 320 by 40, you get 8, no bother. Perimeter then is 40 plus 8 plus another 40 plus another 8, so what you get? 96. Alright, that's pretty easy so far. Okay, it's going to get very difficult in a second. That's question 12. Question 16. The area of a rectangle is 128 meters squared. The length is twice the length of the breadth. Everybody cool with that? So here's what we do instead. The way I do this is, I'd say, no, that won't work. I'm going to call the length 2x and the width x, or 1x. Everybody cool with that? Would everybody agree that area equals length multiplied by width?
Yeah.
So what's the length multiplied by the width? 2x, multiplication, not addition. And that equals 128. Divide across by 2, what you get? X squared equals 64. Square root 64, x equals 8. Once again, the difference between me and you is I want to verify my result. 8 for the breadth, 16 for the width. What's 8 multiplied by 16 in the calculator? 128. I know I'm right. Right, ready? Let's keep moving on. If this question said a ratio of 3 is to 1, what would you do? 3x and x. If it said a ratio of 3 is to 2, 3x and, perfect. Okay, 17. So what have I done now? I've done 8, 9, 11, 12, 16, followed by 17. Now, the problem with this is, guys, it's right angles. That's great. If it didn't tell you it was right angled, how would you figure out it is right angled? What would happen? How would you guarantee it's right angled? You don't. Yes. Alright. When you add the two smaller sides, it has to be longer than the third side. That verifies it's a triangle. It doesn't verify that it's a right angle triangle. So imagine this question wasn't here. Imagine that information wasn't there. How do I verify that this is right angled? Just out of interest. Yes? Do the 17 squared equals 8 squared plus 15 squared. If they equal each other, it's definitely right angles. 289. No need for calculator. There you go. We are at that. Okay. Nextly, we do know it's a right angle triangle because it tells us in the question, but if it didn't tell you in the question, you could always check out Pythagoras' theorem. Now, next thing, a half base times height. So which one's the base? Which one's the height? Has to be where the right angle's located. So the 15 and the 8. A half, 8 times 15, 60, okay? We good with that? Okay, let's keep going, because it's gonna get so much harder in a second. Yep, you said it. You said it best. You said nothing. Okay. Shh. 23. Where's 21 gone? Did I not put 21 in? 23. Oh. Alright, actually, while I'm here, I'm going to take. So, you're told that it's a rectangle, no bother. You've been told that they're using the midpoints every time. Oh, so they're using the midpoints each time. So that would make that 50. It'd make that 50. It'd make that 40. It'd make that 40, and it'd make that 100. Now, I can't get the blue triangle directly, but if I get the 3 white triangles and take them away from the area of the rectangle, that will get me the area of the blue one. So what I'm going to say here is that the area of the rectangle is 80 by 100, which to me is 8,000. And then I have the area of the, we call it the green triangle. The green triangle is the 50 by the 80, so it's a half 50 by the 80. Then I have, we'll call it the blue triangle, which is a half 50 by 40. And then we'll have the red triangle, which I will call a half 40 by 100. I'll lob them all into my calculator and add them all up together. So what's it, 2,000? They all have to be below 8,000, don't they? Otherwise we're in trouble. 1,000 and another. So it's 5,000 for them, which means that one will be 3,000. Not so bad, was it? Looks difficult, but it isn't. Okay, move on. Move on. Okay, 23. The area of the flag covers 1/5 the total area of. Sorry, the area of the circle is 1/5 of the total flag area. If the other two areas are equal, calculate the area of the flag. All right. It's the whole thing, not the flag.
Yeah, it is.
Yeah. So 8 times 10, 80 centimeters squared. Okay with you guys? The area of the circle divided by 5. 16 centimeters squared. Okay, pi r squared is 16. Would you agree with that? Don't even need to do that. I don't even need to do that. Cut the circle in half. That's 8 centimeters squared. This 8 is divided into what? 2 4s, isn't it? 4 times 10, 40. Take away your 8. Everybody cool with that? That one's actually a lot easier than I thought it was. Yes?
Can you not just double the area of the circle since it's 1/5?
If you double the area of the circle, you'll get 32. I don't know why that works, to be honest. What I did there was I halved the flag into the bottom rectangle and just took away the little chunk of circle. Don't know if it's coincidence or not, Charlie. Okay. Shh. Alright, you don't want to do applied maths, don't worry about that. Alright, look at this one. So, with one like this, the deal is with hexagons is that given hexagons make 6 equilateral triangles, each side. It says they're equilateral, so that means everything's A. Shh. Okay, that makes things easier. Area of BSR in third form. Well, BSR is a half base times height. It gives us the height, doesn't it? 4 root 3, so a half base times height, which is going to be a half. It looks impossible, but it isn't. Put that into the calculator and you get 16 root 3. Done. The area of the hexagon in third form. How many triangles make up the hexagon? So multiply your answer by 6. 16 root 3 multiplied by 6. Stop that. 96 root 3.
Yeah.
Is that alright? The perimeter of the hexagon. Sorry, the perimeter is just add all the 8's together, isn't it?
Yeah.
6 times 8.
48.
Alright, that's pretty disappointing actually. Thought I had something good going on there and it just wasn't.